When we have a coefficient of theta, which we used to refer to as the b value when we graphed these problems a while ago, we'll start to get multiple solutions, more than the two that we'd been getting previously when we just had a theta in there. So let's go ahead and take a look at what to do with this. Well, the beginning part of the problem will start out the same way as before. I'm basically going to ignore the 2 in there and just solve the equation sine of theta equals 1/2. And so as we've done before, I'd look at the trig chart to find out what angle has a sine ratio of 1/2, and I'd see that pi over 6 is that angle, which in reality is really just a reference angle. And so then I'd ask myself, okay, well, what quadrants is sine positive in? And sine is positive in quadrant 1, and sine is also positive in quadrant 2. And so that's where I'll draw my two reference angle, pi over 6 and pi over 6 in quadrant 2. And so then remeasuring those angles to get my two solutions, remember this is what we would have done if it was not 2 theta, I'd have a reference angle of pi over 6, or an answer of pi over 6, and if I measure around this way, I'd have an angle of 5 pi over 6. If you need help finding those two parts out, you may want to go back and watch a previous video. And so that's going to be sort of our jumping off point to begin this problem with the 2 theta. Those are not solutions, but they'll help you start the problem. And so on the side here to start actually answering this question, I'm going to write 2 theta equals my first answer, not really an answer, pi over 6. And then also I know that 2 times theta, because that's what I'm really solving for, 2 times theta is also equal to 5 pi over 6. And so solving each of these equations for theta will get me my first actual solutions to this problem. So to do this, I'll go ahead and either divide both sides by 2, or what might be easier to do in your head for this is rather than divide by 2, just multiply by the reciprocal. So multiply both sides by 1/2, and so I get theta is equal to pi over 12. Go ahead and circle that. That is your first of many answers for this problem. So pi over 12, not pi over 6. And then down here, same thing. I'll multiply both sides by 1/2 or divide by 2. It's the same thing. It's just multiplying by 1/2 is easier for me to do in my head, working with fractions. And so this angle then becomes 5 pi over 12. And so those are my first 2 solutions. But the thing that's going to make these problems have many, many more solutions, or at least a few more solutions, is the fact that I've changed the period of this graph, or this function. Remember that when you change the b value, you change the period, which affects how often the graph repeats, and specifically how often our answers repeat. And so to finish this problem, to find our other solutions, we're going to use this old formula for the sine and cosine graph. The period of these was equal to 2 pi, which was the normal period, divided by the b value. And so this equation, if I solve that, or this function, if I solve that little period equation for, I'd have 2 pi divided by the b value, which is 2, and so I find out that the period of this graph, or this function, is pi, which means my answers will repeat every 1 pi. And so what I'll do is, from those 2 answers I circled, I'm going to start adding 1 pi to them. And you may want to use a calculator if you're not good with adding fractions. If you take 1 pi over 12 and add 1 pi to it, that comes out to be 13 pi over 12. And we're going to keep doing this as long as we get numbers that are less than 2 pi, or less than 6.28. Well, no, we're not going to have decimals. So less than 2 pi. So 13 pi over 12 is less than 2. If I add 1 pi again, if I add 1 pi to that again, I'd end up with 25 pi over 12, which is another solution, but it turns out that, remember, it's not less than 2 pi. I know that either by dividing 25 by 12, that's a number bigger than 2, or just think about it this way. We know that 24 pi over 12 is 2. Hopefully we know that, because 24 over 12 is 2. So any numerator that's bigger than 24 is going to be bigger than 2 when you divide it. So even though that's an answer, it's not an answer that's in our domain. So I'm done. 13 pi over 12 was it. But now let's do the same thing with our second answer, our second green answer. I'm going to start adding 1 pi to that. And so adding 1 pi to 5 pi over 12 gets me 17 pi over 12, which is less than 2 pi. So I can circle that answer, since my numerator is less than 24. I could try to add it again, although I'm going to find out real quick that my next answer would also be bigger than 2 pi. And so I get a total of 4 answers for this problem. And one shortcut that we noticed in class was that we usually are getting, not always, but we're usually getting double whatever our b value is. So since my b value was 2, I'm getting 4 answers in the domain that we have, and so that's it. Those are my 4 answers.